Hi, welcome to this Corbettmaths video. In this video, we're going to look at forming and solving quadratic equations. So sometimes you may be asked to solve quadratic equations and those equations will be given to you, but sometimes you may be given a context or a situation where you've actually got to form the quadratic equation first of all, and then solve it. And you may be familiar with doing that with linear equations. You looked probably at how to solve linear equations, and then you looked at how to form and solve linear equations. But now in this video, we're going to look at how to form and solve quadratic equations. So let's have a look at our first example. In this video, I'm going to go through 5 examples for you. So our first question says, Jaden is Y years old, and Rebecca is 6 years older than Jaden, and the product of their ages is 280. And part A says, set up an equation to represent this information. So you want to set up an equation with this information that we've been given. So Jaden is Y years old, Rebecca is 6 years older, and the product, remember the word product in maths means what you get when you multiply two numbers together. So the product of their ages is 280. So when we multiply their ages together, the answer will be 280. Okay, so let's form an algebraic expression for Rebecca's age, because she's 6 years older than Jaden. So if Jaden is Y years old, she's 6 years older, that would be Y plus 6, because it's 6 years older. So that means that his age is Y years old, her age is Y plus 6 years old, and the product, that's what we get when we times them together, will be 280. So let's make an equation. So we're going to write Y, that's Jaden's age, multiplied by, now I'm just going to put it in brackets, Y plus 6, because if you just put Y and then brackets Y plus 6, that means Y times Y plus 6, and that equals 280. And that's it, because in the question we're asked to set up an equation to represent this information, and that's what we've done. Now sometimes in the question it asks you to get it in a particular form, so it may have it in the form of ax squared plus bx plus c equals 0 or something like that, but in this case it just said set up an equation to represent this information. Okay, so that's part A done. So the equation is y bracket y plus 6 close brackets equals 280. You could, if you wanted to, expand the brackets. Y times y is y squared, and y times 6 would be plus 6y equals 280. You could write it as either of those two forms. I probably would just leave it as the top one because it didn't tell us to expand or to make it equal 0 or anything like that. Okay, and then if we go to part B says solve the equation to work out Jaden's age. So we want to solve the equation. Okay, so we have the equation, and I'm going to go back up to this one. So we have the equation y bracket y plus 6 close brackets equals 280. Okay, so let's expand our brackets. So y times y is y squared, and y times 6 is 6y, so plus 6y equals 280. Okay, so we've now got a quadratic equation. And remember with quadratic equations, we like it when they equal 0. So let's take away 280 from both sides of this equation. So on the left hand side, we'd have y squared plus 6y, subtract 280. And on the right hand side of the equation, we'd have that's equal to 0. Okay, so that's fantastic. We've now got our quadratic equation, and one side of that equation is equal to 0. Now, whenever I've got an equation in this form, there's a few different ways we could solve it. We could solve it using factorization. We could use completing the square. We could even use the quadratic formula. Well, what I'm going to do is I'm going to try to factorize it. That would be what I usually attempt first of all. I tend to try and factorize first of all. So bracket, 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 bracket equals 0, just factorizing this. Because it's y squared, we're going to put y's in the front of both brackets. And then we want to find two numbers that will multiply together to be negative 280, but add together to be 6. So I'm thinking in terms of numbers that times together to be minus 280, that could be for numbers such as negative 28 and 10. Now they would times together to be negative 280, but they don't add together to be the 6 that we need, the number in front of the y. Okay, so now I'm going to try 20. So if we try 20, so what would we times 20 by to get negative 280? Well, that'd be negative 14. So actually, let's just check that. 20 times negative 14 is minus 280. And negative 14 plus 20 is equal to 6. So that's fantastic. So in one bracket, we're going to have y plus 20. And in the other bracket, we're going to have minus 14. And that's it. Now, if you need a recap on factorizing quadratics like this, go to Corbettmaths and watch video 117. So there's a dedicated video tutorial there on factorizing quadratics like this. Also, before we do these questions on forming and solving quadratic equations, it's actually quite handy if you actually know how to solve quadratic equations like this already. So if you go back to Corbettmaths and watch the video on solving quadratic equations, that'll be quite useful as well. Okay, so we've now got our two brackets and they times together to be 0. So if we look at this bracket, to make this bracket 0, y would be equal to negative 20. Which isn't possible because remember y is Jaden's age. Or for this bracket, we're going to get that y is equal to 14 because 14 take away 14 is equal to 0. So in terms of this situation, negative 20 wouldn't work, and that means that Jaden would have to be 14 years old because obviously here his age has to be positive. So that means that Jaden is 14 years old. So he's 14 years old. If we were asked Rebecca's age, we'd add on 6, and that would be 20 for her, and 14 times 20 is equal to 280. And that's it, we've solved that question. Okay, let's have a look at our next question. So our next question says a rectangular field is 8 meters longer than it is wide, and the area of the field is 660 meters squared, or 660 square meters. On part A, we've been asked to set up an equation to represent this information, and part B, we've been asked to solve the equation to find the perimeter of the field. Okay, so let's start off by doing a little sketch here. So I'm going to do a sketch of the field. So here we've got a field, and in terms of this field, we know that its length is 8 meters longer than its width. So if we call its width x, so that's x meters, its length would be 8 meters longer. So I'm going to let that be x plus 8 because it's 8 meters longer. So we know the area is 660 meters squared. So to find the area of a rectangle, we multiply the length by the width. So that means if we multiply these together, so we'd have x bracket x plus 8, just put them beside each other, and that means we're multiplying them together, will be equal to 660. Now at this point we could leave our answer like that if we wanted to. I'm going to expand my brackets here to get x squared plus 8x equals 660. And that's it. If part A had actually asked us to get the equation in a particular form, so for instance ax squared plus bx plus c equals 0, I would then take away 660 from both sides of the equation, but the question didn't ask us to do that, so I probably would actually just leave it like this, and that would be my equation. And then part B says solve the equation to find the perimeter of the field. So let's solve this equation, and when we solve this equation we'll find x. So my first step would be to expand my brackets here. So x times x is x squared, and x times 8 is 8x, and that's equal to 660. Now we're going to take away 660 from both sides of the equation to make one side of the quadratic equation equal 0. So that's going to be x squared plus 8x subtract 660 equals 0. Okay, so that's our first step. We've got the quadratic equation equaling 0. Now what I'm going to do is I'm going to factorize the left-hand side here if we can. So I'm going to do bracket, 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 bracket equals 0. And I'm going to put x's at the front of the brackets because we've got x squared here, so it's just going to be x and x. And we want the numbers in the brackets that will times together to be minus 660, and they'll add together to be 8. Okay, with it being 660, I first of all thought of 66 and negative 10, but they're not going to add together to be 8. So I'm then thinking, well, it looks like it's a multiple of 30. So let's try 30. And when we do minus 660 divided by 30, we get that's equal to negative 22. And actually that works. If you do minus 22 plus 30, that's equal to 8. So it's going to be plus 30 and minus 22. So we've factorised now. We want to find our solution, so we want to make both brackets equal to 0. So this bracket, x would be equal to minus 30, or here x would be equal to 22, because to make this bracket 0 it would be minus 30, because minus 30 plus 30 is equal to 0, and here to make this bracket equal to 0 x would have to be 22. Now here x is the width of the field, so minus 30 meters doesn't make sense in this situation, so that means that x has to be 22 meters. So I'm just going to change colour ink here and write 22 meters. That's the width of the field. The length of the field is 8 meters longer, so that's 30 meters. The other width, because we've been asked to find the perimeter here, the other width of the field is 22 meters, and the width here would be 30 meters as well. So to find the perimeter, we just need to add these up. So we're going to do 22 plus 30 plus 22 plus 30, and we'll see what we get. And that's equal to 104. So that means the perimeter of the field is 104 meters, and that's it. Okay, let's have a look at our next question. So our next question says, shown below is a right angled triangle. So we've got this right angled triangle, and the measurements are given in centimeters. So that means the base is x plus 12 centimeters, the height is x minus 2 centimeters, and the hypotenuse is 2x plus 2 centimeters. And we've been asked to show that x squared minus 6x minus 72 is equal to 0. So this time we've been asked to show this. So that means whenever we form our equations, we need to get it in this form whenever we do some simplifying. So here we've got a right angle triangle, and we've got the lengths of the sides. Now I'm thinking Pythagoras' theorem, because we know that a squared plus b squared equals c squared, where a and b are the two shorter sides and c is the hypotenuse, the longer side. So let's write that down. That a squared plus b squared equals c squared. So a squared, that'll be in brackets x minus 2, close bracket squared, plus b squared, that's going to be x plus 12, close bracket squared, equals c squared, which is in this case would be 2x plus 2, close bracket squared. So we've got our sides squared. So what I'm going to do is I'm going to expand each of these brackets. I'm going to square the brackets. And to expand this, we would have to do x minus 2 multiplied by x minus 2. We'd have to do x plus 12 times x plus 12. And we'd have to do 2x plus 2 times 2x plus 2. So let's start off with x minus 2 times x minus 2. Well, x times x is x squared. X times minus 2 would be minus 2x. Minus 2 times x would be minus 2x. And minus 2 times minus 2, well, negative times a negative is a positive, so it's going to be plus 4. And if we simplify this, we get x squared minus 4x plus 4. So that's what this is, our x minus 2 all squared. Okay, now let's work out what x plus 12 multiplied by x plus 12 would be and see what that is. So when we expand our brackets here, x times x is x squared. X times 12 is plus 12x. 12 times x is plus 12x, and then finally 12 times 12 is 144. And then if we simplify these two terms in the middle, we're going to get that's equal to x squared plus 24x plus 144. And then finally we had 2x plus 2 squared, so 2x plus 2, and then in brackets 2x plus 2. Okay, 2x times 2x is 4x squared. 2x times 2 would be plus 4x. 2 times 2x is plus 4x again, and 2 times 2 is plus 4. And then if we simplify the terms in the middle, we're going to get 4x squared plus 8x plus 4. Okay, so that's fantastic. We've expanded our brackets. Okay, so we now know what we get when we expand our brackets, so let's put those back in here. So x minus 2 all squared. So that's going to be in brackets x squared minus 4x plus 4, and then plus, and then x plus 12 squared, that's going to be x squared plus 24x plus 144, and that's going to be equal to 4x squared plus 8x plus 4. Now let's simplify this left-hand side here. X squared plus x squared is 2x squared. Minus 4x plus 24x is plus 20x. And 4 plus 144 is plus 148. And that equals 4x squared plus 8x plus 4. Now I'm actually just going to get rid of our method here. Now obviously if you're doing this in an exam, do not rub this out. It's very important you keep it there on your page. But I'm just going to get rid of it to give us a bit more room here on the page. So if we go back up here, so we want to get it in this form, x squared minus 6x minus 72 equals 0. Now here we've got 2x squared and 4x squared. Now the x squared is positive, so I'm going to bring everything to the right hand side. So, okay, so I'm going to start off by taking away 2x squared from both sides of the equation. So we get 20x. So we get 20x plus 148 equals 2x squared plus 8x plus 4. So we've just taken away 2x squared from both sides of the equation. Now let's take 20x away from both sides of the equation. So take away 20x from both sides. So on the left hand side we'd get 148. On the right hand side we'd have 2x squared. We had 8x, we're taking 20x away, so it'll be minus 12x, and then we've still got our plus 4. We're almost there. Now let's get rid of the 148. So let's take away 148 from the left hand side and take away 148 from the right hand side. So on the left hand side we'll be left with 0. On the right hand side we've got 2x squared minus 12x. We had 4, we're taking away 148, so it'll be minus 144. Now if we go back up to what we're trying to find, we've got x squared minus 6x minus 72 equals 0. But here we've got 2x squared minus 12x minus 144. So if we divide everything by 2, we're going to get 0. 0 divided by 2 is equal to 0. And the right hand side we'd get x squared minus 6x minus 72. And that's it. That's what we're asked to show. And that's it. So we've proved it. Okay. And then if we have a look at part B, part B says to find x, so we want to find x. So we've got this quadratic equation, so what we're going to do is we're going to solve it. So I'm just going to write it out, x squared subtract 6x minus 72 equals 0. Now to solve this, I'm going to try and factorize it. So bracket, 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 bracket equals 0. And because it's x squared, we're going to put x's at the front of both brackets. So an x there and an x there. So we're looking for two numbers now that would times together to be negative 72. And then when we add them together, we get negative 6. So because it's negative 72, one's going to be positive and one's going to be negative. Perhaps 12 and 6. 6 times 12. So I'm thinking negative 12 and positive 6. Because negative 12 times 6 is negative 72, and negative 12 plus 6 is equal to negative 6. So that's fantastic. So it's going to be x minus 12 and x plus 6. So now we've found our two brackets, and we know they times together to be equal to 0. What we're going to do is we're going to make each bracket 0. So for this bracket, x would be equal to 12, and for this bracket, x would be equal to negative 6. Now if we go back up to the question, we're dealing with a triangle here, and we've got x minus 2 being the height of the triangle. If x was equal to negative 6, we'd have negative 6 subtract 2, which is negative 8, and the height of this triangle cannot be negative 8 centimeters. So in this situation, the value of negative 6 would not work, so that means that x would have to be equal to 12, and that's it, x is equal to 12. Okay, let's look at our next question, question number 4. So question number 4 says the base of a triangle is x centimeters, and the height of the triangle is 25 centimeters longer than twice the base, and the area of the triangle is 225 centimeters squared, and we've been asked to work out the height of the triangle. Okay, now this time we've been asked to find the height of the triangle. There's not a part A and a part B, we've just got to work out the height of the triangle. So what we're going to have to do is we're going to have to form the quadratic equation and solve it to answer the question. Now if we have a look at this, we've got a triangle and we're told its base is x centimeters and its height is 25 centimeters longer than twice the base. Well, twice the base, well, double that would be 2x, but it's 25 centimeters longer than twice the base. So that means the height of the triangle would be 2x plus 25 centimeters, because if the base is x, if the height is 25 centimeters longer than twice the base, we'd double the base to be 2x and add 25. Okay, so that's fantastic. We've now got the base of the triangle and the height of the triangle. And we could do a little sketch of a triangle if we wanted to. So we could just draw a little triangle. Okay, so that's our little sketch of our triangle. And we're told the area is 225 centimeters squared. So that's fantastic. Now we want to find the height of the triangle, so we want to find this height. Now to do this, what I'm going to do is I'm going to form a quadratic equation, because I know to find the area of a triangle, I would do the base times the height divided by 2, and that'd be equal to the area. Now, if we take the base and times it by the height and divide it by 2, we get 225. Well, that means that if we times the 225 by 2, that'll be 450, and that's what the base times the height would be. So I would write down the base times the height, which is 2x plus 25, would be equal to 450. And what I've done there is I've just said, well, if the base times the height divided by 2 is equal to 225, if we double the 225, which is 450, that means the base times the height is 450. Now you could have actually written it out in full. You could have said half the base, so half x, the base, times the height, which is 2x plus 25, is equal to 225. And then you could say, to get rid of this half, you could just multiply both sides of the equation by 2. So we can multiply the left-hand side of the equation by 2 to get rid of the half, because 2 times a half is 1. So that's get rid of the half there. And if you times 225 by 2, you get 450. Okay, so that's fantastic. So we've now got the base times the height is equal to 450. Now what I'm going to do is I'm going to expand the brackets here. So x times 2x is 2x squared, and x times 25 will be plus 25x. So here we've expanded the brackets, and we've still got that's equal to 450. Okay, so now we want to solve this quadratic equation. It doesn't equal 0, so I'm going to take away 450 from both sides of this equation. So the left-hand side would become 2x squared plus 25x minus 450, and the right-hand side of the equation would become 0, just taking away 450 from both sides of the equation. Okay, now we want to solve this, so let's try and factorize it. So bracket, 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 and hopefully it'll factorize. Because it's 2x squared, we're going to put 2x in the front of one bracket and x in the front of the other bracket. So we've got 2x and x. And we want two numbers that will times together to be minus 450. And when we put those two numbers in the brackets and expand the brackets, we get 25x. I'm actually thinking perhaps if we choose something such as 45 and minus 10, would that be actually a bit closer? So if we were to put the 45 here and the 10 here, the minus 10 here, so plus 45 and minus 10, 2x times x is 2x squared. 2x times minus 10 would be minus 20x, plus 45x is the 25x, fantastic, and then we've got the minus 450, so that would work. Now in terms of those factorizations that are a little bit harder, whenever we're here we had 2x squared, if you go to Corbettmaths and watch video number 118, there's a dedicated video tutorial there on factorizing harder quadratics, and that'd be quite useful for you as well. Now there is another technique called the split in the middle technique, and you're welcome to use that approach if you wanted to, but I use inspection. I think just the more practice you do of inspection, then you can figure them out. Okay, now if we have a look here, this bracket, to make this bracket equal to 0, x would be equal to 10. And for this bracket, I'm going to let it equal 0, so I'm going to write 2x plus 45 equals 0. I'm going to take away 45 from both sides to get the 2x equals negative 45. And then I'm going to divide by 2 to get the x is equal to minus 22.5. So that means that x is either minus 22.5 or x is equal to 10. Now remember that x was the base of the triangle, so it can't actually be equal to minus 22.5. So that means that x would have to be equal to 10. Now the question actually asks us to find the height of the triangle, and the height of the triangle is 2x plus 25, so we're going to substitute in 10 into there. So we're going to do 2 times 10, which is 20, and then plus 25, which would be 45. So that means the height of the triangle would be 45 centimeters, and that's it. And the base of it would be 10, because we found out that x was 10. And just to check that, 10 times 45 is 450, divided by 2 is 225 centimeters squared, so that's right. So in terms of our answer, the height of the triangle, that's 45 centimeters, and that's it. So that question, we had to form the quadratic equation and solve it to find the height of the triangle. Okay, and let's look at one last question. Now this last example is a little bit different than the ones we've looked at so far. Our first situation, we dealt with the product of some ages, so we formed some algebraic expressions, and the word product meant we were going to times them together, and we formed that equation. Then we had 3 examples that looked at shapes. We had the area of a rectangle, we had Pythagoras' theorem, and we also had the area of a triangle. Now we can't actually predict exactly what situations you may need to form and solve quadratic equations in. For instance, I've seen probability questions where you need to form and solve equations, because with the tree diagram, remember you multiply the probabilities along the branches, so that means that you may need to multiply some algebraic expressions, and it may form a quadratic that you need to solve. It may be a question where you're dealing with objects moving, so whenever you look at mechanics later on, and you look at objects moving, you may need to form and solve a quadratic equation there. It could be even a situation where you have a quadratic graph and you want to find where it crosses the x-axis. So there's a whole range of situations where we need to form and solve a quadratic equation. But here's another one, and this one we're dealing with indices. So our indices, so remember our laws of indices, that if you got two things with the same base, such as y to the power 4 times y to the power 3, that's equal to y to the power of 7, because you add the powers together. If you had things such as y to the power of 8 divided by y to the power of 2, you take away the powers and you get y to the power of 6. And finally, if you've got a power of a power, so if you had y cubed squared, you would times the powers together, and that would give you y to the power of 6, because this is y cubed squared, so you're timesing it by itself, so it's y cubed times y cubed, and then if you do 3 plus 3, that's equal to 6, or the shortcut is to just times the powers together. And as you can see here, we've got a power of a power. So let's get rid of this working out here, and then let's work out this question. So here we have got 5 to the power of x minus 6, close brackets, to the power of x minus 4 equals 125. And we've been asked to find the possible values of x. So here what we're going to do is we're going to look at this, and I can see we've got a power of a power here, so we're going to times the powers together, but we've got it equal to 125. Now that's not a coincidence, because 125 is a power of 5. If you've got 5 to the power of 1, that's equal to 5. 5 squared is equal to 25, and 5 cubed is equal to 125. So if 125 is equal to 5 cubed, and I've done that on purpose in this question, and whenever you're dealing with questions like this, you'll often find that this number will be this number to a certain power. So what I'm going to do is I'm going to rewrite this. So instead of writing 125, I'm going to write 5 cubed, and the fact that it's 5 is linked to the fact that this is 5. So we've got 5 to the power of x minus 6, close brackets, to the power of x minus 4 is equal to 5 cubed. Now what we're going to do is we're going to look at the fact here we've got a power of a power, and we would times the two powers together. So if we were to do that, we would have on the left hand side 5 to the power of, now we'd times the two powers together, so I'm just going to put them in brackets and put them beside each other. So I'm just putting the x minus 6 and the x minus 4 beside each other here in brackets, because you're timesing the two powers together. And that's equal to 5 to the power of 3. Now here you've got 5 to the power of something equals 5 cubed. These two powers must be the same. If this is equal to 3 on the right hand side, this power must be 3 as well. So that means that x minus 6 times x minus 4 would have to be equal to 3. So let's write that down. So x minus 6 multiplied by x minus 4 would have to be equal to 3, because these two powers have to be the same. If this is 3, this is equal to 3. Okay? Now you can see we're forming this quadratic equation. We're going to expand our brackets and then bring it all over to one side, hopefully factorize it and get our values of x. So let's do that. So if we expand our brackets here, x times x is x squared, x times minus 4 is minus 4x, minus 6 times x is minus 6x, and finally minus 6 times minus 4 would be plus 24, because a negative times a negative is a positive, and 6 times 4 is 24, and that's equal to 3. Okay, now let's simplify these two terms here. So that'll be x squared minus 10x, because minus 4x take away 6x would be minus 10x. And then plus 24 equals 3. Okay, now we've got this quadratic equation. We want it to equal 0, so let's take away 3 from both sides of the equation. So let's do that. So on the left-hand side, if we take away 3, we'd get x squared minus 10x plus 21, taking away 3. And taking away 3 from the other side would leave us with 0. So this is fantastic. We can now factorize this, hopefully. So bracket, 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 bracket equals 0. And we're going to put x's at the front of both brackets. It's x squared, so that's quite a nice question. And the two numbers we're looking for will times together to be 21 and add together to be negative 10. So that means that they're both going to be negatives, because the negative times a negative is a positive, but they're going to add together to be a negative. And I'm thinking 7 and 3, because negative 7 and negative 3, they would times together to be 21, and they'd add together to be minus 10. So that means that our solutions would be here for this bracket, x is equal to 7, or x would be equal to 3. So there are two possible values of x. And the question said the possible values of x, so let's just go up and check that. Yep, we're asked to find the possible values of x. Well, x would be equal to 3 or 7. So they're the two possible values of x, either 3 or 7. And that's it. And well, let's check our answer. If x was equal to 7, we would have 5 to the power of 7 take away 6. Well, 7 take away 6 is 1, so that'd be 5 to the power of 1. And then that's going to be to the power of, well, 7 take away 4 is equal to 3. And then we've got 5 to the power of 1 to the power of 3. Well, we times the powers together, so that'd be 5 to the power of 3. And 5 cubed is 125. So that means that 7 works. In terms of 3, we'd have 5, let's go down here, 5 to the power of. 3 take away 6 would be negative 3. And then we would do 3 take away 4, which is negative 1. And then if we times the powers together, negative 3 times negative 1 is equal to 3. So that'll be 5 cubed as well. So that means that 3 works as well. So that's it. And that's it. I think that question was a little bit harder than the other ones, but it's just to show you that you may encounter different situations where you may need to form and solve quadratic equations, and they may not just be rectangles of fields or areas of triangles or Pythagoras' theorem. It may be situations involving probability or laws of indices and things like that as well. And that's it. So in this video, we've looked at how to form and solve quadratic equations, and I really hope you found it useful. And if you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers. Bye.